line, stick it up, and get in at the negotiation.
The snow is gone, and this video, as I promised in my last one, is going to be a technical video. And although it's not going to be the voltage tester, it's not going to be the relay tray, it's going to be a radio repair that I'm undertaking. And I just thought it would be nice to just share with you how I found the fault on this particular Cossor radio. It's quite an old radio, it's not the one that's here, that's a Philips. What's needed to repair this this really interesting and vintage radio. So here I am, and this is the tech video, long promised. The radio we're looking at is the Cossor 487 AC, and by the way, AC doesn't stand for AC, it stands for Alfred Charles, the founder of the company. Anyway, this particular radio is very collectible, and the one I have in front of me has no output whatsoever. It's absolutely dead. So let's get started and have a look at it. A little bit of history. Cossor produced valves in the 1920s but came late to radios. It was not until 1927 that they produced the Melody Maker kit, which got a lot of people interested in radio. They had their headquarters in Clerkenwell, London, and it was there that they produced and started manufacturing radios. They also produced the first oscilloscope and were the manufacturers of an early radar system. I've removed the chassis from the cabinet just to and cleaned it up quite a lot. It was really dirty with cobwebs and dust accumulated over the years. As you can see, this set has the original Cossor valve lineup in it. It has the QM10, the QM66, the QM4, the 6V6G, and the rectifier valve, which is the 6X5G, and these are all in place. First checks I did on the DC output on the anode of the rectifier were good. They were about 200 volts, and that was fine. I'm now going to be checking on the feed from the HT line to the output transformer, and again I have 200 volts there. That's absolutely fine. Now the test here is to, if I move that out of the way, is now to check the other side of the output transformer, and I've traced that as coming in on this yellow cable here, and I actually have minus 0.7 of a 0.007 of a volt, so there's something minus 7 volts actually, so that would indicate that the output transformer is open circuit. And for a start off on fault finding, this it's one of the first checks I always make, but that is very encouraging. I've actually found the fault. So now what I have to do is, let me just turn all this off, is remove the disconnect the output transformer primary and do a continuity check on it. So to check the transformer, we need to remove it from the chassis, and this is me doing that, and then do some continuity checks on the primary, and there it is, removed. Well, there's the output transformer removed, and I've got my meter connected across the primary of the transformer. Already checked the secondary, and that's absolutely fine. And as you can see, my meter is reading open circuit, it's overload. So that confirms that the primary of the output transformer is indeed open circuit, which would account for the reason for no clicks or anything from the loudspeaker. Let's just have a quick look at the circuit diagram so I can just show you how that actually happens. I'm sorry for those of you who are well familiar with output transformers on vintage radios, but I just thought it would be a useful tutorial just to explain what's happening here. Oh, a little bit out of focus, that's better. So what we got here is the DC, which is being supplied by the full wave rectifier, for the rectifier here rather, and in onto these two smoothing capacitors, and then DC here about 200 volts should be coming down through the transformer. So I've got a voltage here which is correct, nothing here, and I have checked that capacitor and that's fine, but there's nothing on the anode of the output valve, and therefore nothing there, so there's nothing coming out of the loudspeaker here, and that really accounts for why we can't hear anything. So the next job is to source an output transformer and to replace it, and once that's done we can start looking to see if there are any other faults on the radio. So that's what I'm going to be doing now. Probably have to get one from RS Components because I don't have one of these available, so let's have a look at that. Well, I hope you found that, I hope you enjoyed that, and if you didn't enjoy it, I hope you found it informative and maybe just a little bit interesting. I know this subject can be incredibly boring if you haven't got an interest in it, but I find it absolutely fascinating to get these old machines back to life again and working properly. It's incredibly satisfying, and it's a really nice thing to do, although it is quite time consuming. My next video will be of a similar theme, but I doubt whether it'll be the bush, because I have real problems with the IF stage on the bush, and it's going to take a while to get it sorted out properly because it was lack of tuning. But nevertheless, I will be back before too long with another video, and I'm going to say this as I always say on all my videos: take care, and I will be back soon. Bye.
Alright, stick her up and get in at the negotiation.